Operation 1. Initial pressurization. To introduce CO2 into the system, connect the CO2 cylinder to the bulkhead. You'll find this at the top right of the system, behind the collectors. After opening the cylinder, CO2 flows through the pipework, passing through the condenser and towards the CO2 filter, to either a manual valve, MV1, or an optional automated valve, as depicted here. The automated valve is activated by compressed air and is controlled through the SFXE software. Operation 2. Pressurization of the CO2 pump. After opening MV1 or activating the automated valve through the software, the CO2 proceeds through the valve, enters the flow meter, and ultimately reaches the pump. Operation 3. Pressurization to the vessel inlet. The CO2 travels from the pump, passing through the preheater, and reaches the vessel inlet valves, MV4, located on vessel 1, dual vessel configuration, and MV7, located on vessel 2, single vessel configuration, as shown here. Operation 4. Pressurization of the extraction vessel. On opening the inlet valves, CO2 begins to fill the extraction vessel. Operation 5. Pre-pressurisation of the cyclone. To make sure you have consistent collection conditions, it's recommended to pre-pressurise the cyclone or cyclones before starting the system. This can be done by opening MV11. By pre-pressurising the cyclone before starting the system, the collection conditions are equalised. This helps the retention of the more volatile components at the beginning of the extraction. Note, to avoid creating a bypass that directs the collected materials straight to the recycle line, it is essential to close MV11 before initiating the extraction process. Operation 6. Opening the vessel outlet. After pressurizing the vessels, you can open the vessel outlet valves, MV5 in dual vessel configuration or MV8 in single vessel configuration. This redirects the flow to the ABPR, automatic back pressure regulator. Operation 7. From the ABPR to the cyclones. The flow of CO2 passes through the ABPR, continues into the vaporizer, and ultimately enters the cyclones. The pressure in each cyclone can be adjusted using the manual back pressure regulators. By adjusting both the temperature and pressure in the collectors, a density gradient is created, helping to separate out different classes of compounds. Operation 8. Material collection. To collect any substance accumulated in the cyclones, just open the respective valve linked to the suitable collector. When the cyclones are pressurized, the accumulated material is expelled through the valve into the vent box found beneath the collectors. The material can then be expelled into a suitable container positioned below each collection vessel. Operation 9. Venting the extractors. After completing the extraction process, depressurization of the pressure vessels can be accomplished by opening the respective vent valves, MV6 for vessel 1 in a dual vessel configuration or MV9 for vessel 2 in a single vessel configuration. Operation 10. Priming the Co-solvent pump. Before using the Co-solvent pump, It's important to prime the lines to eliminate any air within the system. To do this, place the inlet pipe into a suitable solvent bottle and open the left-hand valve on MV2. Once the pump is initiated, solvent will gradually begin to flow through the open pipe, indicating that the lines are now successfully primed. Operation 11. Co-solvent modification of the CO2 or cleaning. Once the co-solvent pump is primed, you can introduce solvent into the system for two purposes: to modify the CO2 stream and facilitate the extraction of more polar compounds, or to clean the system when necessary. To achieve this, simply open the right-hand valve of MV2. Operation 12. Co-solvent cleaning of the ABPR. In the event that material adheres to the ABPR or the pipework and is not being stored in the collectors, the addition of solvent can help flush the material through to the cyclones. To do this, open MV3. This diverts the solvent to the ABPR, bypassing the extraction vessel and preventing any disruption to the extraction procedure. Operation 13. Extraction. Vent mode. The system can be operated in two distinct modes using a three-way valve, MV14. In vent mode, CO2 is directed to the vent line and expelled from the system, enabling the minimum collection pressure to be set to below CO2 bottle pressure. In this mode, there is no recycling of CO2. Operation 14. Extraction. Recycle mode. The second mode involves the CO2 being redirected back to the condenser from the last collector, enabling the system to recycle CO2 during the extraction process. However, it is crucial to emphasize that at the conclusion of the extraction, all the CO2 must be vented and cannot be retained without the addition of a recycle tank. During the depressurization of the system, it's necessary to turn valve MV14 to the vent position. In recycle mode, there is no expansion space available without the addition of a recycle tank, hence the importance of venting. Operation 15. Safety. To safeguard against overpressurization, the system includes multiple safety devices. In the event that the pressure exceeds the safe limit, the rupture discs swiftly burst, allowing for the rapid release of pressure.